My name is Bob Grinion and I'm a volunteer with the Martin Fleischmann Memorial Project. I'm here at Elia Foundation with Honza, who's going to walk me through the VEGA replication apparatus. So what have we got here, Honza?
So what you can see here is the power supply control panel of our EVA experiment. We have a PWM modulation generator which provides the up to 10 kilohertz power output to be voltage transformed up to a number of kilovolts. You can see that our scales are up to 3 kilovolts, but we rarely exceed 2. So after the transformation, there is a DC or rectifier which converts it to DC. Then we have a filtering or smoothing out cap, which does all its best to make the output voltage constant and smooth. But it depends on frequency of that is generated by the PWM machine, and it can be set with this potentiometer from 1.8 kilohertz to up to 9.5. But there's also a PC control mode which can set it up to 10 kilohertz.
So run me through the controls here.
Yeah,
so
right.
what do we got?
This is the main power switch. It switches on all of the power and especially the controls for the power relays. This one switches between the computer controlled and manual controlled modes. This one switches off the 3-phase power input. That's the
big
main,
fat connector over here.
That's the big cable which provides.
And this is the 3-phase variac, yeah?
Yes. You can moderate it or set it to lower values, which we usually do. This 1-phase power input is for the power supply for our PWM generator. Here, this one switches on or off our output cap discharger. So for now, for example, it's on and does its job.
That's the big capacitor bank down here, yeah?
Exactly.
Okay.
You can see that it's already discharged. The voltage is 0. Now, these 3 controls are for the PWM generator itself. So this switches it on. This one controls the power, the duty cycle from 0 to maximum, 100%, and the frequency we've already mentioned. And now we have this row of measuring instruments. So this voltmeter measures the internal DC bus voltage for the PWM generator. This tiny oscilloscope shows what happens at the output of the PWM generator. And after the transformation and rectification, we measure the high voltage, the DC high voltage, with this voltmeter, and after auxiliary, helping ballast, it goes directly to the chamber, and the voltage on the chamber is shown here.
Okay. And that's the current, yeah?
And this is the current through chamber and the ballast.
Okay, and that's your emergency stop button.
Exactly, yes.
And so the chamber itself is over here, and you've got a PC control for monitoring and gathering data.
That's mainly for the manual, for the PC controlled mode, but it should have its role when it's all set up, even in the manual mode.
Okay, and then over here is the actual first chamber that we've just been doing a quick recording of, right?
Exactly.
And this is our shielding, is it? For
yeah, that's for the anode voltage.
Anode. That's where the danger is really on this one. Yes.
Yes, yes, because it's the high powered, high voltage output.
Yeah. Okay.
As you can see, the experiment generated a lot of heat, and our temperature sensors
they just dropped off, didn't they?
Dropped off.
Yeah.
So we have to glue them up more efficiently.
Clamp them on.
Maybe.
Have some actual clamp fixtures on there, and you can clamp them on.
Yeah, perhaps.
Okay, so I've suggested we have one fused quartz so that we can see any UV. And this is your pressure.
That's actually vacuum meter.
Vacuum meter, okay, yeah. And this is the roughing vacuum port, is it?
Yes, that's
down to the vacuum pump here.
Vacuum pump, right.
Okay. And then this one here is the
vacuum gauge.
Vacuum gauge and the analog one. Okay, and we've got another viewport here. Well, thank you very much, Honza. That was fantastic.
You are very welcome. And